This video is for Geometry Chapter 11, Lesson number 3 on area of polygons, particularly area of regular polygons, and then reviewing some area formulas for other polygons and circles. So the first part is on the area of regular polygons, and if a polygon is regular, then that means that all the sides and the angles are congruent. So this is an example of a regular pentagon because it has 5 sides. And there's a new vocabulary word in here called the apothem, and that's the line segment that goes from the center of the polygon down to the middle of one of the sides, and it's perpendicular to that side. So it's this line right here. And that's helpful because if I was going to find the area of this polygon by breaking it into 5 congruent triangles, then those triangles would look like this. And the apothem is the height of one of those triangles. It's not the height of the regular polygon, but it's the height of one of the 5 triangles in the shape. So if I were going to find the area of all 5 of these triangles, then I would kind of make a plan, and I would say that my area is 5 times the area of one of the triangles. And that means that my area is 5 for the fact that there are 1, 2, 3, 4, 5 triangles, and the area of one of them is 1/2 the base times the height. And then to find the base and the height, I have to look at the shape here. Now the base is meaning the base of the triangle, and if I'm picturing this triangle here, then I know that this side is 8 centimeters because it's a regular pentagon, which means all of the sides are 8 centimeters. And the height of each triangle is 5.5. This apothem length is the height of the triangle. So the base is 8 and the height is 5.5. And then I would multiply those together. I could get rid of the half because this half of 8 is just 4, so that's an easy one to use to get the fraction out of the picture there. But you could have just left it here and typed it into the calculator here, or you can type it in here, or maybe you can do that one in your head. It comes out to be 110, and this is centimeters, so this is square centimeters. So the area of that regular pentagon can be found by finding the area of one triangle and then multiplying it by the number of triangles in the shape. And if it's a pentagon, there'll be 5 congruent triangles. There is a formula to find the area of a regular polygon, and it is probably a little easier to use because you can just have the formula written on a note sheet, and it is that the area is equal to half of the apothem times the perimeter. So if you know the apothem is 5.5, then you can just say that this is 1/2 the apothem, 5.5, and then you would need the perimeter of this shape, which would be 8 plus 8 plus 8 plus 8 plus 8, or 8 times 5. And you could have figured out the perimeter ahead of time and just written it down. You could just say, oh, the perimeter of this is 8 times 5, or 40, and then you could just put a 40 in there. So you might have just started with 5.5 times 40, and then if you multiply, half of 40 is 20 times 5.5 also comes out to be 110, which you should know that it should have been because both of these are finding the area of the same pentagon just using a different method. And notice here that this line, 5 times 1/2 base times height, for finding the area of the triangles, is the same numbers here. 1/2, 5.5, and 8 times 5. So the order of the numbers are different, but they come out the same. So anyway, we frequently use the area equals 1/2 the apothem times the perimeter to find the area of a regular polygon. So you could pause the video now and try this one on your own, or maybe do one more with me and then try this one on your own. So I'm going to use the formula that the area is equal to 1/2 the apothem times the perimeter. I'm going to need to know the perimeter though, so we could maybe figure that out first. The perimeter is going to equal to however many sides there are in this shape, which if I start here, that's 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon, it has 8 sides, and each side is 12.4. So all you have to do is either add 12.4 8 times, or do 8 times 12.4, which comes out to be 99.2 centimeters. So then the area is equal to 1/2 the apothem, which is 15, times the perimeter, which is 99.2. So I'm going to do 0.5 times 15 times 99.2, and the area comes out to be 744 centimeters squared, or square centimeters. So the perimeter you have to get, and it depends on how many sides there are in the figure, so you got to count them up. This one had 8 sides, and that number affects your perimeter. Alright, so you should pause the video and try number 4 to make sure that you know how to find the area of a regular polygon. So to start off with, I want to make sure I know how many sides it has. There are 6 sides, and all of them have a side length of 15. So my perimeter is going to equal 6 times 15, which is 90. So then the area is 1/2 the apothem, which is 13, times the perimeter, which is 90. So 0.5 times 13 times 90 comes out to be 585, and this didn't have any units on it, so technically I should say square units. If you leave that off sometimes, we kind of let it go, so we practice the formulas, but it is a good idea to keep in mind that when you're finding area, that it's square units. You're finding out how many little squares are in each shape. It would be fine if you wanted to do these problems by how we did number 1 up here. On this one, you could say, here's a triangle, and there are 6 of those triangles. So if you wanted to use a different method here, you could say that there are 6 triangles, and each one is 1/2 the base, which is 15, times the height, which is 13. And that will get you the same result as 1/2 the apothem times the perimeter. That's just by finding the area of 6 triangles, of one triangle, and then multiplying it by 6. Alright, I thought it would be a good idea to quickly review the other area formulas that you know already. Any rectangle or square, you know that the area for that is the base times the height, where that's the base and that's the height. It's a rectangle if all the angles are right angles. So a parallelogram's area is also base times height, because you could just picture this little triangle coming over here, and then it forms a rectangle. So the area is just base times height, where this is the base and this is the height. A triangle, we've already been through this a couple times today, is just 1/2 the base times the height, and that's the height, and this is the base. The trapezoid we've done earlier in the school year, but you need to know that the parallel sides are considered the bases, base 1 and base 2, and the height is the distance between the bases. And the area is 1/2 base 1 plus base 2 times the height. The area of the circle you've been working on is equal to pi times the radius squared, where that length is the radius, and the circumference of a circle is 2 pi r. The circumference, remember, is the distance around. And you could write a formula for the perimeter of some of these shapes, but it's just adding up the outside. On this one, you could say the perimeter is 2 bases plus 2 heights. But here, you don't, the b and the h don't form the perimeter because you don't know how long this slanty side is. So it's kind of not really worth it to try to write a perimeter formula, but you do need a formula to find the circumference of a circle. The regular polygon, the one that we just used, is equal to, the area is equal to 1/2. You might want to write the word apothem times perimeter, or 1/2 AP, and probably fill in that that's the apothem. Alright, and then this is not for the area, but I thought that it would be good to have the Pythagorean theorem on this sheet. A squared plus b squared equals c squared. And remember that that always has to be the leg squared plus the leg squared equals the hypotenuse squared. So that's it for the notes, and the homework is just the second page of this document. It has 8 questions on it, and I thought I'd just give you a couple hints for them. You should just stop the video and only come back here if you need the hints. But so, for example, on number 5, you're finding the area of a trapezoid, and you need to know base 1 and base 2 and the height. The base 2 isn't given directly, but you can tell from the way the bottom is labeled that that distance is 25. You can add those values together to get that value. But you're going to need to do the Pythagorean theorem to find what h is. So this h, you'll have to say 8 squared plus h squared is equal to 17 squared. And then once you know h, you'll be able to do the formula for the area of the trapezoid as 1/2 base 1 base 2 times h. When you do question 8, it's also a trapezoid, which I gave you that information, but these are your bases. It doesn't matter which one's base 1 and base 2. But it looks a little funny because it's on its side, or it's just rotated from what a normal trapezoid might look like. You could also try to do the problem by breaking it up into a rectangle and a triangle, but I think it'll be easier this way. And there's another one I wanted to tell you something about. Well, I guess you can try it from there. You'll need the Pythagorean theorem a couple times to find a missing piece. And on your sheet, there should be answers down here at the bottom for you to check. And just show your work out nicely. If you can't print the documents, as always, just try to do your best to recreate them in your notebook. I think drawing the figures is helpful, but not essential if you can figure it out without it. So there you go. Good luck on the homework, and thanks for watching.